So in this question here, we have a graph which shows the speed of a car in meters per second during the first 20 seconds of a journey. And we can see the graph here. So we have speed in meters per second on the y-axis and then time in seconds on the x-axis. And we're asked to work out an estimate for the distance travelled by the car in the first 20 seconds of motion. And to do this, we're asked to use 4 strips of equal width. So looking at the graph, we have a graph of speed against time, and we're looking to find distance. Now, if I think about the formula, distance is going to be equal to speed times by time, multiplied by time. So if we have speed on the y-axis, time on the x-axis, if we multiply them together, we're actually finding the area of the graph. So the distance is going to be the area underneath the line, underneath the curve. And we're asked to use 4 strips of equal width to calculate this. So if the maximum time is 20 seconds, we can divide this by 4 to get the strip width that we're going to use. So the width of the strip is going to be 5. So we can split this into strips of width 5. So starting at 5 seconds and then one at 10 seconds, one at 15, and then the final at 20. Now we can remember here that this is just an estimate, so we're not looking for the exact value. The lines aren't going to quite perfectly match up with the curve, so we can kind of approximate these as would commonly use trapezia to do this. So for example, over here, if we were to connect these two up, we're pretty much going to stay on the line. So that would create a trapezium here. And again, at this point, another trapezium and another one here. And then finally here, if we were to make a trapezium, this side would have no length as it goes through the point 0, 0. So here we're just simply going to connect that point to this point and make it into a triangle. Now obviously there is quite a lot of area here which is left unaccounted for, but this is okay. We're just looking to calculate an estimate. So we appreciate that this isn't going to be an accurate value, it's just a rough idea. So we can now estimate the distance the car travelled by adding up the areas of each of these shapes that we've created. So this triangle and then these 3 trapezia. So we can calculate the area. So here, the area of this triangle, half the base times the height. So we have a half multiplied by the base, which is the width, so 5, multiplied by the height here, which is 22. So a half times 5 times 22 gives us the area of the triangle, and that's going to be 55. And then here, the trapezium, the first one, the area of a trapezium is half the sum of the parallel sides times the height between them. It's a handy little rhyme. So we can do the sum of the parallel sides, so these 2 sides are the parallel sides, and this one is 22, and this one here is 28. So we can find half of the sum of the parallel sides, so 22 plus 28, times the height between them, which is the width of the bar, so 5. And that's the area of this trapezium, which is going to give us 125. We can then do this one as well using the same formula. So half the sum of the parallel sides, this time we have 28 and 32. So a half times 28 plus 32 times 5, again, which is the height between them. And then finally here, half the sum of 28 plus, 32 plus 35. So we can just take that as being 32 plus 35 times the height between them, which is just 5 again. And just quickly putting the totals in here, that one would be 150, and then this one is going to be 167.5. Now, estimating the distance, we just need to find the sum of all of these strips that we've calculated. So 55 plus 125 plus 150 plus 167.5 is going to give us a final answer of what we have here, which is going to be, if we just put that into the calculator, 55 plus 125 plus 150 plus 167.5 gives us 497.5. So as for how the marks are awarded here, you get the first mark for using a method to find the area of one strip using trapezia. So one of these will get us the first mark. The second mark is for a complete correct method to find the area using all 4 of the strips. So using all 4 of them. And then the third and final mark is for an answer in the range of 488 to 507. There's a little bit of leeway just to account for kind of different readings having been taken from using the strips and that kind of thing. Answers may differ slightly. You could also use rectangles to estimate the area, and that's going to give you different values still. Now for part B of this question, we're asked whether the answer to part A is an underestimate or an overestimate of the actual distance the car travelled in the first 20 seconds. And we're asked to give a reason for this answer. So thinking back to the first part of the question, I did touch upon the idea that the answer isn't going to be entirely accurate. It is an estimate, and that's because some of the area below the graph isn't included. So all of the trapezia and the triangle in particular means that there is area under the graph, under the line, that isn't going to be included when we're calculating the area of these shapes. So as there's area that's not included, it's going to be an underestimate because the distance should actually be greater, more squares should have been counted, but because we were approximating it with triangles and trapezia that were smaller than the area, it is in fact going to be an underestimate. So to get the marks here, I'm just going to put underestimate. We're stating that it is an underestimate, and that's going to be since parts are not included below the graph. It might make sense to put the word some in here. So some parts are not included below the graph when they should be to get the accurate distance. So therefore it's an underestimate because not all of the area has been taken into account. So that gets us the mark here. We have to make sure that we state it is an underestimate and then go on to explain why.